Hello, everyone. Thank you for being part of this call. Uh, Now let me share my video. Screen. Okay, so let's give like a few more minutes. I am expecting a few more folks to join, and as soon as we have maybe like 3 more minutes, maybe we can join after that. We can start after that. Um, by then, I'm just launching a simple poll that you can start answering. It's a simple poll to just gauge the experience, um, your backgrounds that will help us customize our platform or even our future presentations. And you could also see Agent Bot in this. So Agent Bot is something that can help you with answering any questions that you have. So if you have any questions, just tag Agent Bot, Agent Versity Bot. It can answer those questions. It can also make those questions really hyper personalized based on um, your background. So please make use of it. So throughout this call, like if you have any questions, please do drop a message in the comment section that I'll revisit after every few slides. Today we are also going to see a bit of hands-on session on um, how we can build this LangGraph agent. There was a pre-work that was sent. If you couldn't complete it, that's fine. Um, uh, we have a Discord channel that you can join later on, like whenever you are trying to work on that. And if you have any questions, please do ask us in the Discord channel. We can help you out with getting you. So we can help you out with completing the task. Let me share this Discord channel here. Um, Let me share that. Okay. So I'm sharing the Discord channel within the group. Feel free to join that. And Sai, if you can add this into Agent Versity Bot, that would be great. Like if regarding tasks and all.
Yeah, sure. From next week.
Thank you. Um, okay. So we have 16 people. We can get started. So before that, I just want to ask how many of you have worked with AWS prior to this call? Okay, Don, I see you. Thank you for raising your hand. Anyone other than Don, like you can raise your hands, or maybe there's a if you don't want to react. Okay, that's good. Okay, 3, 4, 5. Okay, I see. Okay, that's good. It's a good number. So you've already worked with AWS, so you're already aware of a lot of things on AWS, but today we will be discussing a bit more on the AWS AgentCore. So, if you are pretty new to AWS or haven't used AWS before, this is not a introduction to AWS. It's a bit more advanced than that. We'll be just talking about a service within AWS. Or if you have worked on building an AI agent, you could still follow along this course. So AI agent using LangGraph is something that we're going to cover today. So you could just follow along. If you AWS is more of a cloud environment, so they have agent code is just to productionize your agent. That's what agent core services is all about. If anyone is new to AWS, you could always, we'll give you some documentation if you want to get started. So, but at least just make sure that you have some basic understanding of some some services, but we're not covering a lot of services. We'll be only looking at few agentic components in this call. So, yeah, let's go. I'll go ahead and get started. And my slides, I'll share my slides, but I might go away from slides a bit because I want to cover some of the fundamentals on what is an AI agent if someone wants to just look at it and understand what AI agents are, because some of the jargons that we're going to use during this call would probably be related to AI agents. So let me go ahead and share my screen. Okay. So So we're going to talk about the Amazon Bedrock Agent Core services. So Agent Core, so Amazon Bedrock is a service altogether which has a bunch of LLMs in there. You can already build AI agents with those existing services itself. We already did a session on that long back, and Agent Core is primarily meant to productionize existing frameworks. Like you already built an AI agent in LangGraph or Crew AI or any other frameworks. It's a model agnostic, framework agnostic service that will help you productionize your agent. So if anyone, if since all of you are familiar with AWS, who all are familiar with AWS, you know already IAM roles or any of the existing permissions, granular level permissions that you could give for any service, or even existing guardrails which are already in place. I think those all apply, including Lambda functions, if it's any kind of serverless components. So it's actually built on those existing services itself. So I'll go through overview and highlights, but before that, I want to cover a bit. If anyone of you are not aware of LangGraph, we will cover LangGraph very briefly. Maybe I'll go through some few concepts on how LangGraph works, and how you build agents around using LangGraph. And the code overview that we have does cover a few of those concepts as well. So while doing the code review, I'll also go through them, those concepts too. Um, so, and also, what is an AI agent? That's also one of the things which I wanted to cover over here. Um, so, okay. So I wanted to put this in the graph, but I didn't have time. There's quite a few going on with my, on my side of stuff. So, um, let me go ahead and just give you a small example on what is an AI agent. So, a AI agent is something that is a wrapper on an LLM. LLMs are large language models, which hopefully everyone is aware of, like models which are powering your ChatGPT product, or it could be any other products like Claude, or Perplexity. So they are all wrappers around a LLM, a large language model. So a chat GPT could probably give you different answers, but maybe it may not act on those answers. Like it may not make payments. Maybe they're doing that pretty soon. They're integrating apps into it. But if you see an AI agent is something that is powered by an LLM that performs a specific actions. Today we are going to build a marketing or market stock analysis agent, that will actually study markets, or any question that you have about the stock markets, you can probably ask it. That's something that we're going to build today. But in this example, if you see there's an AI agent, it's powered by an LLM, and a user who asks a prompt, a AI agent could use different tools to answer that question. So it uses maybe a code executor. It could also get some, any document from external sources in order to answer that specific question. So that is what an AI agent is. I think I love this diagram because this gives every details. So this is an AI agent, and there are few fundamental components. This is tool. A tool is nothing but an AI agent uses to provide you with a response. While if in case you ask about the current date, or maybe you ask it to do some math, the agent should know it has to use a calculator to do math. it should know it has to use a code interpreter to probably write some code to do some data analysis. Maybe you give an Excel sheet, you're asking it to just go and study the Excel sheet and provide you with the highest, maybe a number or maybe a entry which is highest. It has to write code to analyze your data. So it needs a code interpreter. It can also use browser to search for different data as well. So these are all different tools that an AI agent would make use of to do something useful for you. A customer support agent would probably use, ticketing system to solve some problems, or maybe it refers to your documentation to answer a customer's question, or it even does refund off processes, or maybe your refund for any product. So these are something that an agent could do, agent which is powered by LLM could do, but it does need to have access to a tool. And an agent should also have access to memory, because memory is a very important thing. It should have access to two different kinds of memory. One is short-term memory, the other one is long-term memory. Short-term memory is maybe when you're chatting with ChatGPT, you are solving a problem, or maybe you're trying to create a blog. You usually have back and forth conversations. That's all stored in the short-term memory because that's a working memory for your AI agent. And there could be some stuff that is long-term memory as well. Like if you go into ChatGPT and just ask it, hey, tell me about me, what do you think, or tell me everything about me, it would probably give you all of the information about you, anything that you have chatted with it. It might persist at some data if you enable that feature in ChatGPT, because it's storing everything in long-term memory. Maybe your preferences, maybe how old you are, and what you do, where do you work, what are your preferences. I think these are all something that a AI LLM or AI agent can actually store in terms of long-term memory. And even when you're building an AI agent for your enterprises or maybe for your startup, even those AI agents, if they really want, if someone is to feel that to be really smart, memory will make them really smart, because they can, maybe your personal AI agent should remember who are your best friends. Maybe tomorrow you are not best friends with someone and you just ask it to go and book a table. It should know it should exclude that person from that booking, because the long-term memory would have persisted that the friend is not that he's not your friend anymore, right? So that's something that a long-term memory would take care of. It should know what to persist long term. And planning is something an LLM already inherently does that. So it does by reflection, self-critic, chain of thoughts. So these are all something that LLM itself has those traits that it uses to reflect on the answer that it has given. Maybe if the answer is not does not have a lot of empathy, because when you're dealing with a customer who's frustrated, then it should probably reflect on its answers and come back with a better response, right? So this is part of the planning section. And action is just something that when agent want to act, it uses tools to act on it. That's the reason why you see the tools is pointing to action. So this overall is just an abstraction, like how an agent works. Because while we're going through the slides, we might be talking about places where we say a tool is called, or we may talk about some memory components. So I just wanted to let you guys know how these all things work together to make an AI agent. Um, So let me jump back into the slides. And before that, I just also want to talk a bit about LangGraph framework. So as you know, okay, there is an AI agent that is just like, that is just like a AI agent that is using a specific, it's probably doing a specific action, right? But how to build them? I know ChatGPT is a product. Maybe most of you in this call might have used that product. But how you when you want to create an AI agent for an enterprise, or any of your small businesses, or maybe for your startup or a side project, if you're a DevOps engineer, maybe you're building a AI agent as a DevOps AI agent, or maybe a co-pilot for yourself, or maybe creating content, right? These are different use cases you can build an AI agent for. So how do you build them, right? Just like every we're building them programmatically. So when you're building programmatically, then comes the frameworks, and LangGraph is just one of the framework that you can use to build an AI agent. So it's a really big framework. I mean, I think today they announced they had like 1.2 billion valuation, that they got a lot of investments from a lot of different companies, and it is a framework that is used in production, by the way. So the reason why it's highly used in production is it's not too opinionated, and also this framework works by creating different nodes. So if you see here, um, each of these frameworks, let me give you a simple example. So if you see, this is a simple agent that if in case we want to build that, it's a simple RAG system that they're building. Every part of the LLM interaction, anything that LLM has to interact, it is treated as a node. So you're basically creating different nodes for different part of your workflow. And also your agentic workflow. You're also doing conditional edges where you can move, you can actually create conditions if in case based on the user feedback or based on the previous actions, it can actually generate or it can rewrite something. These are some of the things that you can do. Or maybe a supervisor agent, a user question that needs to be sent to different agents when you're building a multi-agent system. Previously, we have seen only a single agent, but imagine now we have three or four different agents. Maybe you're creating a team of software engineers, agents. Maybe a supervisor agent has to assign a task to this agent. Maybe a tester agent that has access to certain tools, and this is a developer agent who has access to some tools, and this is maybe a product manager agent who has access to some tools. So a supervisor agent would coordinate all of this. So when you want to create this cognitive architecture, yeah, LangGraph really plays a key role here by creating nodes and also creating different edges to those nodes. And that way you're basically adding deterministic nature to a stochastic system, right? Because LLMs are, when you give LLMs power to do anything, they could probably do anything. They can hallucinate. But when you are defining different nodes and edges, you have this control on what's going on with your system. You're basically creating a workflow. You're restricting the AI agent not to do what it meant to be doing. Like it cannot just go and call a different tool at different time. It cannot do that because now you have all this conditional edges and all this orchestration that you can build into the system. So that's a beauty of LangGraph. If anyone wants to work a bit deeper into the, I mean, if you want to look into it, you could use any of the existing. They have a great documentation. You can probably spin up a simple AI agent and build the system by yourself. There are also other frameworks like Crew AI. Crew AI is probably is also a different framework. Most of you might be familiar. It's not as complicated as LangGraph because Crew AI has lot of prompts already inbuilt. And it is easy to work with. And OpenAI also has their own OpenAI SDK, and as of now, they came with Agent SDK. Claude also came up with their own SDK. So if you see the Claude Agent SDK, so this is also one of the things that they just came up with. So every provider is coming with their own SDKs and frameworks. Um, and LangGraph is definitely, is way ahead. It's been there since 2022. It's actually part of LangChain, and it's been it has actively developed, and a lot of people are using it already. Okay, let's get back to our slides and we can go a bit more deeper into this now because I just wanted to give that background because if anyone is in this call and while we're going through the code, we must touch LangGraph because the agent that we're going to build today is actually a market research or a market analyst agent. So we're using LangGraph for that. And also, since it's an agent, you should be able to know what is the tool, what is memory, and all of that. Um, I just want to give a brief maybe a pause to see, is AWS the Amazon version of Azure or Google Cloud? Yes, that's right, Mo. It's just like Azure or Google Cloud, and AWS has been there for a very long time. I think they are the first to begin with this. Um, begin the cloud journey, like I think in 2007 or 2006. And AWS is the one which really got into trouble like a few days ago, where they did maybe a small issue in US East. It just got down almost half of the internet, like many apps were down. And I think our event is just happening a couple of days after that, or maybe a day after that. So will there be a recording for this in YouTube? Yes, we do have a stream of this. So you can always look for Agent University channel on YouTube and you'll have this recording there. So Cloud Code is an agent example. uh Claude Code. So Claude Code is not, I mean, it is agent because it's only specific to a domain, right? Because Claude Code, it's actually working to write code. So it's also it's an agent that can help you to write code, but it's more of a configurable agent that you can, ask it to. You can create a claude.md file and all of it and have it run. So yeah, Claude Code is an agent itself. Like, I mean, when I say Claude Code, it has agentic nature in it because it does know when to look for when to research for any library. It does know whether your code is working properly or not, because after it wrote the code, it probably executes your unit test cases parallelly. And also it has something called Claude agents, sub agents, which it can create sub agents to do the review of the code that it has written. So it is agentic to some extent. So you can you can actually see them in action probably. I do have Cloud Core in my local, but yeah, it's if you see this is how the agent architecture is. It does have a multi-agent coordinator. It got planning engine, decision engine. There's a UI layer that comes into picture, but this is tool and integration. I think it's just a generic agentic architecture they have built, but Cloud also works a similar way. It also has a memory of it, so it does know what it has written previously. So yeah, it is a agent itself in itself. So Cloud Code is an LangChain and LangGraph difference. Okay, the difference between both of them is Cloud Code is an agent that is already built. It's a software agent that is already built out, and now you are the customer, you're consumer for it. But you can still tweak that agent to build your software. You can put guardrails in there using Claude.md file. Your prompting is something that you can customize. So it's already a built agent for a specific domain that is coding domain. But in LangChain and LangGraph are more of frameworks. So you can build any agent with it. You can also build Claude agent or Claude code with LangGraph if you want. Because end of the day, what are these agents? They are all wrappers around an LLM, right? So you could also build something like Claude code using LangGraph as well. So
My
that's
last question is sorry, that so there is LangChain and the LangGraph. They both are different frameworks
oh yeah.
to create the agents,
Yes,
workflow
they both
agent.
are. Yeah, they both are a bit different frameworks. It's LangChain was the initial version. Then they have the latest version that they start calling LangGraph, but still under the hood they use LangChain itself. The some of the tools and all of them are actually created by they're used by LangChain. So they natively those are existing in LangChain, and LangGraph was actually built on LangChain's ecosystem. So they are kind of part of the same ecosystem, LangGraph and LangChain. Hopefully that answered your question. So LangGraph has a bit more robust abstractions now to build a bit of more robust memory features. It also has states. So LangGraph has a lot of states that you can, when you're building an AI agent, it does store the state for every execution. So that's the beauty of LangGraph. So even when your server is down, or maybe the system failed, resiliency is built into LangGraph. LangChain is not as robust as LangGraph. So LangChain does help LangGraph to do a lot of these things. But LangGraph is built on a lot of LangChain itself. Okay, it's more of a dependency. Oh yeah, if you have multi-agents, yes, you will use LangGraph. Yes. So if you have multi-agent systems, you can use LangGraph. That's also one of the reasons why you could use LangGraph. But in production, you could use LangGraph. But if you want more examples on like what is the exact difference, I think you can always ask AgentBot. I think it can give you some more responses on this. Um, but hopefully that makes sense. They're part of the same ecosystem. And if you really want to build with it, you can do even LangChain or LangGraph. But LangGraph is something that everyone uses in production. Um, so let's go ahead and look at this presentation now. Okay. So I'll be just going over this briefly, and we'll also go through the console and look at different parts of this service. Um, so So what is Amazon Bedrock Agent Core? So it does provide framework model and model agnostic, so you can build AI agents, and you could. It's basically a runtime. I can say it's basically providing you with runtime and tools and all of the agent ecosystem. Like when you want to build agent, you need probably a place to run that agent, right? You need compute. You also need tools to access tools. You need memory to access memory, right? These are some things which we already discussed, and that's what Amazon Bedrock Agent Core actually provides it. So it can work with any agent framework. So Crew AI, LangChain, Strands. Strands is also something I've seen a lot of examples with Strands that they have provided. I have never worked with Strands. If you have worked, please let me know. And model inside and outside Bedrock you can use. Enterprise grade security, obviously, AWS is built a lot of security guardrails that are in place. So it does provide true session isolation, embedded identity, and secrets management. These are some things that it does provide. Like you can create secrets management. I mean, even if when you're creating an AI agent, or maybe you're building a startup, or maybe an enterprise application, these really play a significant role. That's the difference between having a production ready application versus a non-production ready is, secrets management. Any developer who's been working on cloud native applications does already know this. But anyone who's new to this, yeah, this is what makes your application production ready. All of these guardrails, session isolation and identity and all of them, and scalable and serverless, because even if you build an AI agent, if that is built with serverless, so you are only charged when it is executed. So it's not that your compute is already running. So if someone uses it, that is when you pay for it. So, and it's also highly scalable. Obviously, it's Amazon, so definitely they have a scalable infrastructure. They can provide instantly scale to thousands of agents. So you can, if your agent is really a hit, now you can just scale them to thousands of asynchronous tasks that you can do perform. So they're saying you can scale to thousands, and you can also perform asynchronous tasks up to 8 hours. So that's a good thing. Like, your systems can still keep on running for 8 hours. Maybe there's a scientific discovery AI agent that you're spinning up that does a lot of number crunching, a lot of data that it gets into, and just does some research. Yeah, maybe you can still do that. You can do that with this infrastructure. Composable services. So you can mix and match runtimes. You have memory, identity, gateway tools, and observability. All of these are a lot of them are already inbuilt. So when they say mix and match runtime is okay, maybe you could either use the agent core specific runtime, or you can also see another runtime, and then you can probably integrate them together. So some of the use cases, I mean, there's a lot of use cases. I don't want to discuss this into detail. You can create customer support, web automation, research analysis, finance and operations bot, workflow automation, a lot of SaaS APIs that you want to integrate. You could do that, secure chatbots. And one of the important feature which I've seen is you can convert existing APIs into MCPs. That's a great use case. And anyone who's already built some APIs in your environment, in your enterprise, and you want to convert that into an MCP server, you could do that with AWS Bedrock. They do support that by providing different templates and all. And so runtime is basically the compute. It's basically a secure serverless execution with full session isolation. So that's the runtime that they provide. So your request is isolated, and it's also running in serverless. So you're not paying it for the compute all the time. Memory, yeah, it does support short-term and long-term memory. So as we discussed previously, you know the difference between short-term and long-term memory. Short-term is something that's happening like now, like maybe a working memory of it when it's working on a specific task, and long-term is something that has to be persisting over time. Identity is already, if you're already aware of AWS, it does have a lot of enterprise authentication, secrets management that's already provided out of the box. And it does have gateway, which is you could transform APIs and Lambda functions into agent tools. So you build an AI agent, maybe there is an API in your enterprise, maybe you build an API to submit tickets to Jira, right? And you could transform that as an agent tool. So when you build an agent tool and you want to transform that as a tool to an agent, when an agent calls that based on a workflow, you could probably do that with this gateway feature. Code interpreter does provide secure sandboxes. So AI agents, when they are trying to code, you definitely need an environment that is isolated. You can't give access to your own laptop. I mean, yeah, a lot of people are doing that. They might have given access from Cloud Core to run autonomously, but it's a huge security risk, right? Because when Cloud Code goes out and downloads some rogue images, or maybe some libraries which are not authorized, then usually your system is at risk. So you need to have a secure sandbox for different environments. So the AWS Agent Core service provide that for you, a code interpreter as well. And you probably need browsers too, like to interact with the web to check, to research on various maybe a documentation that it has to go and get information about. Yeah, browsers are really important because all the time when you write crawlers may not always work. Sometimes you need a browser to just look for or click through some buttons and understand the UI, because that's possible because these LLMs are multimodal in nature. So they can understand images. So if they understand an image, they can also understand a browser environment. They can look at a browser and understand where to click, what to do. So that really helps a browser, a AI agent to click through different browsers and just navigate just like how we humans are doing now. Um, Observability is something, in production, right? So observability is important. Observability is just like monitoring. So you need to, I can't directly mix observability and monitoring together, but observability is a bit more proactive. It does goes deeper into different traces, different requests, how every request is flowing. That might be very important for you when you're building a system that is for production. Authentication is an important aspect here. So it does uses Cognito and other enterprise IDPs as well. So if you already have using any kind of SSO in your enterprise environment, you can always use that out of the box with AWS AgentCore. They have a host agent. You have a runtime that runs agent in a secure session isolated micro VM, because that agent is something that is very sensitive and you don't want to share that infrastructure with other. So you can probably do that as well, which is host agent. And there's also different interactions and monitoring that all works together. So yeah, it's quite it's just the same thing. It's just that when you build an agent locally and now you want to productionize it, I think these are all things that you should think about. About the memory component, authentication, authorization, security, isolation, and all of them. So there are two different abstractions here. The memory is as I remember, we already covered it. It's just a short-term, long-term memory. There's also serverless storage for it. You also have hierarchical organization based on namespace, agent, and session. And runtime is just secure serverless micro VM per session with full isolation that you get. And it does accommodate a lot of various workloads for up to 8 hours. And it also handles lots, thousands of agents. And yeah, it's basically covering all of the previous things that we discussed. So identity and gateway. So identity is something that interaction, it does integrate with existing identity providers. And the gateway is you can transform REST APIs and Lambda functions into agent tools, like you can also do MCP, which we already discussed before. So you could convert a REST API or a Lambda function into an MCP. So if anyone wants to, or they are not aware of MCP, MCP is called Model Context Protocol. It's really, let's say if you're coming from the development world and now you have two different APIs, and maybe you want two different services to talk to each other. So what you do, you basically create an API, and your upstream service or any service want to talk to your service. You have an API, you have different methods that you actually provide. You provide, and it is very strict contract between both the services, right? Because now, if any of the request that is coming to your API, it could be a post, update, get, whatever that request might be. You have a different methods that you follow. So imagine if it is if you are exposing, or if you want an AI agent to use your APIs, right? So AI agent could do that. They can probably use your API, but what you do is, if you expose that with an MCP, if in case you're just using API integration with AI agent interacting with only API, then maybe there could be a second AI agent or third AI agents that all want access to your API. So you do the same plumbing again and again. You again have to do that integration. You again have to put that authentication. You again have to provide some context to your AI agent on what this API or this tool does, right? It's a lot of repetition. It's a lot of plumbing that is repeating again and again, because now your API has really got famous and every agent want to use your API. So if you create an MCP, MCP is basically a wrapper around your API, which which abstracts your API functionality, and also it provides additional context to different AI agents now. So any AI agent that's coming and interacting with your API, if you have an MCP, they can interact that in a streamlined fashion. You don't have to do that plumbing for every AI agent that's trying to talk to you. Now, if you have an MCP, you say, hey, this is my MCP, and your AI agents can talk to this MCP. So the advantage is now every AI agent does know what your MCP does, because now you have that context that you expose, and everything understands that. And now that contract is more flexible. I mean, you're not still dealing with this APIs, strict standard contracts. You still deal with APIs because that is the method in which you flow the data. But still, when you have a MCP that is created, the you're basically trying to have systems. You're trying to create this integration to different AI agents without manually creating all this plumbing again and again for based on every other AI agent. They all can talk through this MCP. It's more of a abstraction that you build around your API. So it's very easy for you to create that with this. I mean, I do agree with them. It's when you want to convert an MCP, I don't think it's a huge deal for you to do that. It's just a wrapper code. So you just have to do some wrapper code. There's also frameworks for that. You just need to follow the framework and just integrate your API into it. So it's not magic. They're just providing you access to it. So even if you want to do it without AWS, you could still do that. So supports context-aware semantic search for tool discovery, and secures invocation and protocol translation with strong authentication. And these are all different built-in connectors. I mean, these connectors are just nothing but again MCPs, right? If you want to connect your AI agent to, now every product has an MCP out there. They all say, hey, now we have an MCP. Now have your AI agents talk to us. So you don't have to get into Slack to see what is a recent message. Rather, you just talk to whatever AI agent that is, and your AI agent would probably go talk to Slack through MCP and get you back your results. It could be MCP, Jira, Zoom, whatever. So that's the beauty of MCPs. So now you have every SaaS product has become an AI agent now, and they all talk to each other using these MCPs. And observability and security limits. Observability is end-to-end tracing, there's metrics and logs. You do have all of this generate. We'll go through this dashboard. I think I don't want to cover too much of the slides, but yeah, they are basically charged per second. And gateway is like, I think it's almost 0.005 cents per thousand tool API invocations, and they also have memory, 25 cents per thousand short-term memory events. So, I mean, if you really want to build a product on AWS, I would maybe if it's an enterprise, yeah, it does make sense because you're already on AWS, and AWS is definitely expensive. But if you're already on AWS, instead of affording to migrate to some other environment, it's easy for you to just get started. And if you feel like your product is doing well, maybe later on you can migrate it onto your own infrastructure. So you don't have to stick with AWS Agents Core, because eventually this will definitely get expensive. Only thing all you have to do is to, since it is a model agnostic and framework agnostic, you have that ability to migrate, and there's no vendor lock-in. So that's the beauty of this service. I mean, you can start off with this, have your MVP out there, you see how there's a lot of traffic that's coming in and your product is a hit because of this. Then you could just go out and migrate it off Agent Core, and you will save a lot of money. Um, okay, Rahman, go ahead. You have a question?
Yeah, only a single question regarding MCP. So, while I was trying to understand the MCP, basically it's just kind of when you mentioned regarding the flexibility of contracts. So, what I understood from the conversation is like we if it is a wrapper onto the APIs, we probably cannot change the contracts. We just like facilitate other tools to understand what that API is doing by giving a context, so that that code won't replicate with respect to, like, for example, like adding a Google Meet, maybe, and like we there is an API for Google Meet, and we want to like utilize it in with respect to different agents. So if there is an MCP for that, we do not have to like kind of write all the conversion code for different agents. And since it has an MCP, any kind of agent can interact with that, right?
Yes, yes,
Okay, thank
absolutely. That's right. So what everyone is saying is, previously vendors or SaaS providers would say, okay, this is my documentation for APIs, and now they just go in there and integrate that with their client application. Right now, client application, it could be LangGraph, you're using Crew AI, you have so many frameworks now, right? When you're using LangGraph, maybe for that they would have a different way of plumbing. Maybe a new agent that is coming in, they have built using Crew AI. Now again, they have to do a different kind of plumbing, right? But what if they all have MCPs, then you don't have to have different plumbing. You just, all the SaaS providers say is, hey, you now have this MCP, and this is what you can get from MCP. Now you can just go and ask me, find all PRs in GitHub, and I'll just give you that result. That's your agent has to do that, right?
Yeah.
And how would you integrate that? Maybe you have an API, and now you just, the model uses that MCP to call API, and it get to the results. So that's a beauty of MCPs,
Thank you.
right? You're reducing. I mean, it's definitely a great protocol. It came out last October. Oh, it's almost been a year. I mean, I can't believe this. Last October 17th or 18th, it got released. I've gone through that. I did speak to. Initially, I felt it was not. I mean, I do know there might be a value. There's a huge value for it, but it really picked up in March or April of this year. That is when it really picked up a lot. But Anthropic is the one who got who created this protocol, MCPs. Yeah, definitely it's a huge value add for all of us. Um, okay, so let's go ahead with the implementation and also walk through the code. I have already shared the code with all of you in this call previously as part of the pre-work. What I will do now is share the I'll share my local IDE and go through that code. So before that, I want to show you exactly where you can find that code. Um, so if you go into GitHub, yeah. So this is the repository. I've already shared this repository in the pre-work that I have sent out. These got a lot of agent code services samples. And if you go into use cases, this is the use case section, and here there are a lot of AI agents. And most of the things which I've seen here is they are already most of these AI agents they're using something called Strand framework, which I haven't done before. But anything is Strand agents. They call it Strand agents, and it's enterprise ready. It looks like it's open source. So I never played around with this, but you could probably use this and check for yourself how it is. Um, how does it work and all? Okay. But today we're going to use LangGraph. So the agent that we're going to use is this market trends agent. So this is the repository that you should probably clone and start working with it to build a to start working with your AI agent. So before that, you need some prerequisites, like you need to have some things installed and some roles created. So if you go into AWS console has uh,
Can you share where did you share this link for the repository?
it should be in the Luma. Did you get the Luma blast before? Or maybe if not, I'll share you the uh, email to you right now. Let me share that content to you.
Can you share that information in the chat? I didn't
Yes,
get it either.
yes, I'm
Oh,
doing that.
perfect.
Yeah.
Thank you.
Um, yeah, there you go. Okay. Okay. If you see this is where we have the all of the process on how to create your AWS account. If you don't have an AWS account, this is there are some links which I've shared here that talks about this on how to create your AWS account. Um, Share this. Okay, I think it should be, yeah. Um, so you probably need a credit card to do this. I already have an AWS account, so I'm just using that as of now. But if not, you could actually use your own AWS account. Um, I mean, you could add, you need to add a credit card for this. So just make sure that just don't create the resource and leave it. I mean, for agent core service, I don't think you will be charged anything. But if in case you're trying to create some huge machines, you will be charged. So no surprise. Please make sure and never share your AWS credit keys or anything with anyone else. But yeah, there is a process that you have to follow, and I've documented the process in the Zoom chat. It will be a great opportunity for you to learn AWS as well. And if you have any questions, maybe you're just starting off, just get into our Discord. We have a separate section where you can actually ask us any questions if you're stuck, so that we help you out with, maybe if you're even starting AWS, we can help you out with some of those questions answered.
One
But
small question is like how much cost I should expect if I'm using any kind of agentic tools here with serverless architecture.
The beauty of serverless is based on number of requests, and I think we have already seen the cost. If you see the cost here is probably for 1,000 tool invocations, you might be charged like 0.05 cents, and then for memory, it's almost a quarter for 1,000 short-term memory events. And for compute, you'll be charged per second pricing based on CPU and memory usage. So it's basically if in case that too, right? If you're using browser or anything per second. So that is also a tool, right? If you're using a specific browser or everything that then you are, and also runtime is usually serverless. So you would only be charged if in case you get requests. So you can express maybe around $2 or $3, not more than that, but try to clean up, right? After you're done with this, just go ahead and clean it up, delete all the resources. I think it should be good enough. You don't have to really worry too much about this. We're not creating GPUs or anything, right? Because GPUs and all will probably charge you a lot. Don't share these keys or anything that you create externally or push them into GitHub. So just make sure those are there, because if you push them to GitHub, there are a lot of bad actors out there who can just exploit your AWS account. They might even come in mine. It happened to me once, 2 years ago, 3 years ago. Someone pushed a GitHub keys, and within 3 hours, $2,000. Just they burned through $2,000 in 3 hours because of that. Because they mined bitcoins with it within 3 hours. So it's definitely a huge risk. So it's a shared responsibility model. Any cloud is a shared responsibility model. So if you really want suggestions on how to go ahead, always use ChatGPT to understand how you can be more proactive in terms of reducing that cost. And also share some documentation with you guys on how to create and how to be careful around the cost. There is some billing alerts that you can create so that you know exactly how much it is costing. But since it is agent core, I'm not too worried because it's all serverless. So you might be charged maybe $1 or not more than that, dollar or $2, unless you're making and putting it for the public, or and just forget about it and people are using it. Maybe yeah, then it might charge you a lot. So yeah, so the next thing is once you create your AWS account, there are a few prerequisites that are mentioned here that you probably need to check as part of this AWS core services. Let me show you what those are. Yeah, these are all runtime. Okay, there's a use case. Okay, let me come here to the market trends agent. So what we're going to do today is to build this. And there is code for this. I'll go through this code and explain how this is done. You could follow along if you have everything set up, or you can just listen through, ask me any questions, and you can slowly follow along this article. Like if you have any questions, as I said, there's a Discord. You can always be part of it and ask questions. So there is a customer, and with in any question, and the customer is actually a broker because it's a market trends agent, where it is a financial advisor agent that we're going to build. So what we're trying to do is, this is the agent runtime, and agent runtime is, this agent is powered by AWS Amazon Bedrock LLM. So the Bedrock service has all the LLMs within it. So you could access Claude agent or Claude LLMs or Llama. There are a bunch of agents that you can use if you go into AWS Bedrock. AWS Bedrock does have it's a shell, and it's almost like Hugging Face. So here if you get into model catalog, the model catalog has a bunch of agents, sorry, a bunch of LLMs which are there. So these LLMs are the ones which are powering an AI agent. So you could click any of these AI LLMs that you want to use. These are all closed closed LLM. So they're not open source, but these are all a bit of open source LLMs that you could use. Today we'll be using Claude LLM. So it's paid. It's based on it's based on per token. Um, and today I think it has to be a multimodal because we're using a browser tool. So it should be a multimodal LLM. But yeah, we'll be going through that. And
One
if you see
question,
the
please.
yes, go ahead.
So if we are using the Claude APIs, do we need to create, I mean, uh, do we need to pay through the Claude, or like the Amazon will take care of all these things? Like, do I need to create an account on Claude to get an API key or things like that, or like Amazon will take care of
No,
that?
Amazon will take care of it, but still you need to you should able to you should able to request access to it. So when you go into Claude, you would have a place where you can actually request access to that. So if you see here, as of now, I have everything already provisioned. But if I want to request access, maybe I have this Claude. I click on it. It's open. I can directly click in open in Playground. But some of the models you might say access should be requested. It should probably take you like maybe 10 minutes to get access. So you just request an access and Amazon gives you an access to it. So you could do that all by yourself.
Okay.
So,
So
but you
from
don't
just
have to create
from
a cloud
AWS.
account though. Billing
Yes.
is through AWS now, right? Billing is through AWS. So you don't have to
Okay.
create a cloud account or you're not trying to sign into cloud because AWS, you are paying AWS to use cloud, and AWS is a big investor in Anthropic. So yeah, they would allow billing through them. Hopefully that makes sense, right?
Yep,
So you
it
don't have to
does. Thank
create
you
a
so much.
cloud. Yeah. And see, if you see, AWS Bedrock already has a way to create agents, knowledge bases, and all of them. But the problem with this is, it's a vendor lock-in, right? I mean, end of the day, there are different ways in which you can create flows, you can create knowledge bases, and all of it. But these are not model or framework agnostic. These are all native to AWS. That's the reason why they came up with Agent Core, which is a bit more, which does provide. When you're building agents, because they know definitely a lot of folks are using agents with their own frameworks, and they want to create this service so that you can make use of all this. So if you see, this is how the agent is, and agent would probably have access to all these resources, and yeah. So let's go through and let's go through this code and review what it is doing here. So if you see the diagram here, the market trends AI agent that actually deployed or running on the AWS agent core runtime, it's using a Amazon Bedrock LLMs, and it is also using some tools. So what are these tools? It is using browser to check for stock data, to search for news. So it is checking all these things from by using a browser. So this agent has a tool that is a browser tool. And you could see the browser tool is already mentioned here in our agent core because agent core already has some built-in tools, and browser use is one of the tools that we can use. So if you see the view built-in tools, this is the built-in tool that you could use, which can actually go out and search for news and everything, right? So and then these are two browser tools, and there's also memory tools because uh, the reason why we treat memory as a tool is because your AI agent should know what it has to persist in long-term memory. It should also know what was the conversation that you had with that agent prior, which is really important. Maybe some data that you have given like few days ago or few months ago, that you need to be able to get that information, retrieve that information, right? That itself is a RAG, and you need a memory tool for that. So that is the reason we create memory tools, which basically collect all the broker preferences. So the broker is nothing but this customer, because what we're doing, this application is basically a broker who creates, who has its own persona, and then they try to they try to use this AI agent to ask for different suggestions. They try to ask questions around what are the trending AI stocks or whatnot, and all of their responses are hyper personalized to this broker. So brokers' interests are something that AI agent would store, and it will basically hyper personalize all of that answers based on the broker's preferences that were stored initially. Okay, so it will first collect the broker preferences interactively. So there is a way to do that. I have created a small UI for this. I haven't pushed that code. The UI is not provided by AWS. So AWS just gave us a code where we can run execute things locally, but I wanted a simple UI. So today I just did that just before the call. So there is also list conversation history. It has to go ahead and list all of the conversation that it has prior. It also has get broker finance profile to look for what is the finance profile of the broker, and also update broker financial interest, because tomorrow broker might say, oh, you know what, I don't want to invest in maybe energy stocks anymore. Maybe I want to invest in gold now, right? So these are some things that it has to update in keep it in financial in its memory, because tomorrow when it is doing the research, it has to know, it has to take into consideration what is the current state of broker's financial interest to do that research, right? So we need that here. And if you see, this is what powered by the agent's core memory. There is also the two types of memory if you see here. One is the user preference memory strategy, then also semantic memory strategy. The two different memory types. One is user preferences. User preferences could be different, and semantic memory is something that stores on based on if you see here the update broker's financial interest, or there could be some semantics within the conversation history, because current output that has to give based on how different data points are linked in the semantics of the previous all of the previous conversation it has. So and all of the requests are sent to agent traces, where you can actually see that in the agent core observability, and you have an agent core browser, which is actually a tool that does research. So these are all agent tools, and this is a tool itself, and this is the memory part, and this is the LLM which does planning and everything. So hopefully
So,
this
uh,
you could recollect or something. Sorry, you can actually relate this to what we have initially discussed, what AI different components of AI agents. Yeah, go ahead.
can you? I wanted to ask question regarding the mem. So I'm like that part is not clear. So
Okay.
yeah. So basically, I see like probably these are kind of functions that in the memory tool. These are functions that are being executed to
Mm-hmm.
store the data in the memory. But
Mm-hmm.
how do we specify? Like, are we talking about the short-term memory? Are we talking about the preferences or the semantic part of it? How can we specify like which type of memory are we talking about?
Um, when you say we're talking about, do you think who is making the decision on what is it? And
Yes, like for
okay.
example, like collect broker preference interactively, right? So
Mm-hmm.
probably this is saving some kind of information related to broker
Mm-hmm.
preferences
Yes.
interaction.
Yes.
So where should this be saved? Should it be
Okay.
saved in the short-term memory, long-term memory?
Yes, that's a good question. So it will probably collect broker. It should be a long-term memory, right? Because when it is trying to collect the broker preferences, because broker preferences are something that it should able to collect it and also store it in a long-term memory, because now the preferences might change. Now the broker might have, he want to, invest in stocks which are really high risk. So that's something that it should be done, and it should be persisted in long term.
But how we can mention? Are like is there a way to specify
Mhm. Yes,
the like types of the memory here?
yes, I'll show you that in the code. It's already done. It's usually done
Okay,
through
okay.
prompting. So in the prompting, I'll show through the code like how it is done. It's just we're looking at the overall architecture.
Sure.
Um, so if you see, the use case type is conversational, agent type is graph. We're using LangGraph for this. There's a financial service is the vertical that you're trying to solve here. It's an advanced complexity, and this is the SDKs that we're using, and we're using Playwright. Playwright is something that does the opening of browsers and all, so we use Playwright for that. Um, and if you see here, there are different advanced memory management, multi-strategy memory, so uses both user preference and semantic memory strategies. There's also broker profiles because it needs to be persistent. And there's also LLM based identity. There's also investment preferences. These are all something that need to be that it does. And LLM based identity is it does know based on, I mean, what it is doing is it's just using LLM itself to match to basically check who is a broker. It doesn't have a login feature, right? Ideally it should have, but it doesn't have a login. They just made sure that it's just a memory call to know who's it chatting with. So this is the real-time market intelligence. It's providing all of these different sources. So it does have different sources where it gets the news from. It also has this personalized market briefing because now it does store the broker's profile. So it does that in a personalized way. There's automatic profile parsing. There's livestock data that it gets from different sources, and just provides that in a specific standard. And this is the browser automation that we are handling just to get the data, which is real-time data. And if you see here, these are all different things that we already discussed prior. So based on that, all you have to do is clone this repository. And if you already have AWS account created and also AWS CLI that is installed. So there's something called AWS CLI that you need to install, and you need to configure that. And if you see, there is a simple command called deploy.py. So what it does is it deploys this agent into into AWS. So deploy.py will go ahead and deploy this, and how it does is just by, if anyone is, since if whoever is aware of AWS would probably understand this way better than others, because when you're doing a deployment in AWS, you have to create execution roles. You need to have trust policies. You create execution policies. These are all jargons of AWS, by the way. So if anyone is really want to understand this, you probably need to know a bit of AWS. So AWS is shared responsibility. So AWS provides physical data center security. They provide all of the resources. It's up to you to secure what you built on AWS. So they provide this IAM. It's nothing but identity and access management. So whatever you provision on AWS, it should have the security inbuilt. So it cannot just go and access any other service directly unless you explicitly allow it. So that is what you're doing here. So you're creating these trust policies because now you want to use AWS Bedrock Agent Code service, and it has to assume that role. So assuming is it's just that it has to be able to use that service, which is a Bedrock Agent Core service, to do something, because our agent is using Agent Core Bedrock to interact with agents or other tools. And these are all execution policies where, since our LLM is powering it, you need invoke model, and you also need invoke model with response stream. These are some permissions, some actions that this code or this whatever code that we're trying to deploy should possess. So that is what these execution policies are. And it might be really tricky even for someone who's been working for AWS for a while. They get stuck here, but still, I mean, when I say stuck, they sometimes, your permissions has to be very granular, and figuring it out is not an easy task. You should probably do a lot of back and forth, and sometimes, Cloud Team doesn't allow stars, the stars that are given here, so there'll be a lot of back and forth. I mean, someone who's a is a cloud or a data engineer here probably would understand our frustration, like how this works really. But yeah, definitely that is needed. But if you're really new to AWS, just you could definitely, you have a lot of learning to do here. But you can obviously use ChatGPT or Client to understand, or maybe Cursor to understand what this code is doing. So you're doing is to create the IAM roles, and then once your IAM roles are created, then you come the deploy agent, and deploy agent is going ahead and deploying your agent. So we're using Python script to deploy. Ideally, in your enterprise, probably you'll be using Terraform or CloudWatch to do that. And if you see here, these are all different ways in which you can start creating. Creating the sorry you can these are ways in which you can deploy this agent, and there are some default role names and everything already pre-created. And once you deploy it, you will get something called as a ARN, which is the runtime ARN. So as soon as you deploy the resource, you get this Amazon resource name that you can use to create that you can use to interact with your resource.
But
So yeah, I think these are, yeah, go ahead.
where are we defining like which instance, like what type of instance is where we are deploying this code? Where are we specifying those things? Where are we like where are we starting that instance, etc.?
So as of now, I don't think here we mention that like in terms of, because now we're using Docker and we're using a, just a minute, let me check here exactly. I don't think we mention here because runtime usually has a, okay, initial runtime. Okay, entry point, agent name, region, and you see here auto create. So ECR is one thing they're using for the Docker. So you're using a Docker image, and now you're using a Lambda to do that, right? You're building a container image and you're creating an agent core runtime. So when you're using an agent core runtime, you don't have to mention which EC2 that you're using because agent core runtime is all Lambdas now. Under the hood, they're using these micro VMs that are really starting really fast and that they're hosting that just like AWS. Are you aware of AWS Lambda?
Yes, I am.
Yes. So if it is AWS Lambda, so they're just trying to create, AWS Agent Core Runtime. Uh, so they're just creating Lambdas for that. So if you see this Agent Core Runtime here, um, yeah, yep. Yes. So they're creating an image and they're pushing that image into AWS Lambda and they're just calling it as a runtime. They're not just actually calling it a Lambda as the name imply. But yeah, that's something that they're using here in the agent core. So they have, looks like they have abstracted that. Um, okay. You see, runtime acts as a containerized application that process user requests, maintain these all things, and integration with Lambda. So if in case you want to integrate this with Agent Core, maybe and here we are basically using or exposing Lambda functions as an external tool, but as far as this where it is running, it might be a micro VM as we discussed before here. I think in the slide as they mentioned that they're using a micro VM to create that runtime, secure and serverless. So it is some kind of serverless entity that is sitting out there and is running. They are not calling it as a Lambda, but still it basically is a micro VM that is really fast to spin up. I mean, Lambdas are also micro VM. They're firecracker VMs that they create behind the under the hood. That's the reason it has a cold start problem, right? You can't directly trigger Lambdas. You need to have it warmed up. So yeah, you're not mentioning any CPUs or anything here, but you're just trying to create a container image and just deploy it. And since it is serverless, you only build charged based on the request that is coming in. Does it make sense?
Yeah, that does like, but I'm confused about one thing. Is
Hmm?
like, yes, it is serverless, right? And we are going to be charged when the request is going to be made. But
Hmm?
how, I mean, and we don't know when we are going to make the request. So means like the instance will always be running and won't be charged.
Yes. No, the instance will not be running.
Then how about the memory? The memory, how are we
It will
retaining the
done. It will
memory?
be done on driven. It will be done on time. Right. Whenever there's a request that is coming in, that is when the instance starts. That is what serverless is all about, right? Because Docker image, how much time does it take for a Docker container to start up and running, boot up and running? So whenever a request comes, that is when it just warms up and just serves your request. Maybe the initial request might be slow, because your VM is slow now. It will take some time to respond back because now the VM has to start and give you a response. But it's cold start problem, right? That is what a problem. That's what happened with it. I mean, that's how Lambdas work.
Yeah, like
Yeah.
I'm trying to understand like the memory, how the memory will be persisted for a long time. Like maybe if we want to extend the memory, according to
Why do
our
you need
use
memory?
case,
Because it's stateless, right? Which memory you're talking about? Is it agent's memory?
agent's memory.
Okay,
Yeah.
agent memory is stateless. So agent itself does know based on the input request, based on what information it has to persist, it just goes and persists it. And your code itself is stateless. What is running in Lambda and in your runtime is stateless. And based on the conversation, it just goes there and persists the information in your agent core memory, which is which is again made of some vector DB in the background, right?
Yes.
Yes, and then it just goes persist that memory. And now whenever your agent comes back, it does know based on the input, based on the payload, it does know which memory ID it has to refer to. We'll see that where the memory IDs and all of them are referred. And that is how it works. And we'll go through the code, then you'll see, okay, there's a memory ID and everything. So every request that is coming,
Okay.
it does know how to go ahead and point to that session based on that previous memory it had.
Okay.
Okay, but it does not put like anything running as a standard. It does not store everything in memory, or it's not a system that is continuously running. It's all decoupled, it is stateless, and any information that it has to persist, it will just go persist in a vector DB, and it later on refers to that by the agent or broker profile that is created. Okay, so yeah, that's the reason why we're not mentioning any instance here, because you see in the AWS Bedrock, you say that build an agent and upload code to ECR. So from ECR, they are basically creating a they're basically using this from that. So
So
and if you
basically,
want
the
to,
Docker, the code for the agent is written in the Docker, which
yes.
is like deployed as an image to the ECR. And whenever we need to execute it, it
Mhm.
create a runtime and get the image and start that agent. But the memory is at somewhere else place. So I was like confused with like the memory that is being written, how we are like persisting that memory. So if it is different place, then that makes sense.
Yes, it is a different place. So this is the memory section. If you see here, you can create a memory where agent will learn and store. So now I've actually created a different agent before, and you'll see that it actually stores all of that code here. It also creates these two long-term memory strategies here. One is the broker preferences, the other one is the market trend semantics. Both of them. Those are stored here, both of the memories. Okay, these are decoupled.
Yeah, okay, makes sense.
Okay. So yeah, let's move. And now you see here, based on this,
Hey,
you
Raj, just one question. The
come on.
memory that we are talking about is being used, so it is not free. We are getting charged for that, right?
I mean, memory is basically a storage, right? Here, the memory is basically a something that is stored as vectors and stored in a vector DB. So you might be getting charged, but not. It's not a memory in the sense. It's not a compute memory. It's just a memory of our agent. And a memory for agent is just a file or maybe something that is stored or written in a vector DB as numbers. So that is what it is.
Okay, so it should be like an EFS or EBS, right?
Yes, yes,
But
absolutely.
then
Okay,
those
they call it
things,
vector DBs, not exactly. I mean, yeah, EFS, these are file systems. EBS is a storage, a block storage. But if the memory for an AI agent is usually a vector database.
yeah, but then it is using something physical, right? And
Yes.
that is not free, right?
Yeah,
Is that
it
correct?
might be. It might be. They might be charging some for. I mean, we already covered that, I guess, in this. I don't know how much they're charging for that memory, but yeah. Okay, memory is 25 cents per thousand short-term memory events. So it's also event driven because now they're doing retrieval, isn't it? So even though you
Oh,
have a memory stored somewhere, but just like how S3 has the, if you have a number of requests, based on the ingress or how much data flow in and out that you get charged, same thing here that's happening, but you're basically getting charged per how many events that are happening because now it has to go ahead and retrieve that memory, right?
yeah,
So it's basically charging based on that. Yeah.
there is no mention here of the long-term memory that might be needed so that this retrieval can go ahead, right?
Yes, I mean you could. I mean, let's see how much is that pricing. We could probably know that here. I'm in terms of memory. Yeah. So yeah, this is long term. So usually built-in memory strategies. So this is 1,000 records stored per month. So and okay, so they're saying 1,000 memories you are storing per month, you're getting charged 75 cents. And using built-in with override or self-managed memory strategies, this is 25 cents per thousand memory records stored per month. So if you're using like a self-managed memory strategy or something, but still your agent runtime is actually retrieving that, or if you're using a built-in memory strategy, then you're basically using like for 1,000 memory records stored per month. So there are some
Okay.
strategies that they have, and the long-term memory retrieval. It's like 50 cents for memory retrieval. So it's mainly event driven, how many retrievals you do, even if it's long term or short term. But as your data increases,
Okay.
yeah, obviously AWS charges for that too, right?
Okay. Well, thank you for that clarification.
Yeah, no problem. But yeah, great question. Thank you. Um, Okay, where are we now? Okay, so that is something that so this is where you have your runtime that's created, and you're basically deploying that. And yeah, you could see here, yeah, it's ideally you'll be using Terraform, but yeah, they're using a Python script called deploy.py, and you just execute this, it just deploys. It's just single command, and you're using UV, by the way. You're not using pip. I don't know how many of you use UV, but I would recommend UV. You start using UV from now as your Python. I mean, I just started using it. I never did that before, but yeah, it's really great. And you do UV sync. It just installs all your dependencies, and then you just run one command called UV run Python and deploy, and it will just go and deploy. I've already done that here previously in one of in let me see my sessions previously. So I've already installed and deployed yeah, and deployed it. So it should be straightforward. It is not a yeah, it is not a complicated step. And I was able to install it probably in once you have your AWS configured, so the things that you need is your AWS CLI. So when you do type AWS in your local, you should probably have something like this. It should recognize AWS is a command, and if you have AWS installed locally, you can interact with your AWS console. Previously, when you see anything that you're doing here, it's a console access. So now I can go into the UI and look for different steps here. But when you have it in a CLI, you are actually configuring AWS from your CLI. So it requires authentication. You need to create some credentials. You need to create a keys for that. So how do you create keys? I think I've shared all of those documentation in the chat that you can follow. If you have any questions with it, you can always ask us on Discord, or you could always use ChatGPT to get yourself familiar with it. Just taking instructions from ChatGPT and run with it. So it should work fairly simple, but yeah, AWS could be, if you are starting, it could be overwhelming because AWS has so many things. It got so many. The UI is really intriguing. I mean, it's not user friendly by any chance, but they've been in the game for a very long time. And if you see the market share, AWS has a huge market share. So if someone in this call, if you're looking for a job, maybe in any enterprise, so definitely learn some cloud. It could be AWS or Azure or GCP. You better do that because most of the firms do use something, some cloud or the other. And having cloud experience definitely adds a lot of value to your resume. So, and if you're doing AI agents on cloud, even better valuable because when you go into an enterprise, there are a lot of folks who want to create agents, but you know, um, your barrier to entry to create agents is really low when you know cloud. So yeah. Um, so the next thing is, so once you do that, once you execute UV deploy, it just goes ahead and deploys it. I have already deployed it. And you once you deploy it, you'll see this. It's called Market Stock Agent. I have created that today. And as you've seen here, this is the ECR image URL. This is where my image has been built and pushed. The image which I'm talking about is the Docker image that has been pushed, built, and pushed. You would see that instructions in the deploy.py on how that is done. And this is the latest image. And after that, yeah. So once it is deployed, now you see this is the UI for your agent core service. The agent runtime is created. Now my image is built and pushed here. And there's also an endpoint that is created because endpoint is the one from which every all of the client code will interact with. So any clients that you create, as of now, I created a client locally. I've created a simple UI code that can do that. So if you see this UI.py, it's a simple UI. I have used Gradio to create this. And AWS doesn't provide you with a UI. So they just give you in the code, in the actual code, they have just given ways to work from the CLI. So they haven't provided any UI. So I've just created a simple UI. I'll share this code to you guys on our GitHub and share this with you so that you can also try it locally. Um, and if you see the deploy.py is something that we have looked at. We know this will just deploy the code. But so let's get into like how the actual agent code looks like, right? If you see this market trends.py, the uh, yeah, this is the entry point where your app is created, or it's an entry point for your ad. For your app. And if you see here, app is Bedrock Agent Core app. So it's instantiating from this. It's called Bedrock Agent Core app. This is a shell that AWS Bedrock Agent Core provides, with runtime and everything. If you see here, we're also importing LangGraph. We need LangGraph. This is the state graph because, as previously said, LangGraph is based on this graph that you create with different nodes. And there's some methods that you import. And after that, you also have AWS Bedrock agent core, and also different tools that you create, like create memory tools. You also have tools to parse broker profiles. So there's different tools that you create, and tools are something that you have created. I've created some tools here. We'll go through it, what each and every tool does. But yeah, just be aware of these packages, and I'll want to go to where how things start. So given a user query, how it goes, how it flows into the system. So a user query would probably get here as a prompt, and the payload is sent to our the payload is sent to our agent. And if you see here, there is also something called human message. Human message is something from LangGraph. These are all different constructs they've created prior that will basically use the user input, and it just extracts the final message from this. So there could be a bunch of back and forth messages, but they want to just see the final message because that is something that needs to be processed, and that's returned from the market trends agent runtime. So the prompt that the user gives is actually returned from this. And if you see, there are two different functions here. One is the runtime, which is the agent runtime, and this is the local. So this is used for testing. So they both are the similar functions, but one is done locally and one is done in the actual runtime. And if you see here, I think someone asked me, sorry, Rehman asked me, if how do you know how the agent knows which memory to use, right? It's all part of system prompt. I'll show that here. So what's going on here is uh, we are basically building this memory now, right? So there's a create memory function. So there are two things to this. One is the memory client and then the memory ID. So memory ID is the one that identifies how your memory is stored, and 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 what memory it has to refer to based on the profile, right? Every broker would have a memory ID, so it has to refer to that memory ID to retrieve all the memories related to that broker. And there's also a memory client. So these both are something that you would use by create instantiating, like by using create memory. And then comes the session ID that you need to store, because you need to create this session ID for all of the conversations. And then you have a default actor ID. So as I said, this agent that AWS provides as an example, it doesn't have an authentication in place. It doesn't have a Ideally, we'll have an authentication wherever, even in enterprise, you have SSO. So you basically have the authentication. And I'm not saying agent code doesn't have that. They do have it, but this example doesn't have it. So if I want to show you in agent core how authentication works, it's very robust. I really like their documentation that they have provided. I want to show you a simple diagram. I really like the diagram which I've provided. So there are two types of authentications that exist here. Um, so including even from MCPs, or even it's coming from okay, let me go into the main dashboard. I think this is where I've seen it. Identity. Yeah, if you see, I like this diagram because it's really cool. So let's say every hosted image, there are two kinds of authentication. So one is the inbound authentication. So you are authenticating someone who's calling in, maybe a user I want to interact with your agent. There's an inbound authentication. And your agent, it has to call to an external MCP server, or it would also be external resource, or it could also be a gateway. So these are all outbound auth. So how it is able to authenticate to an external API key or an OAuth client, or it could also be a tool, or it could also be something else. So how do you create that? As of now, this agent that we're building, it doesn't have that in place. It's not that robust. It's just an example. We're just going through this, but if you really want to explore more complicated ones, they have very great examples to even explore them. So we'll probably do that later on. If you all are interested, we could do that. But if you see here, the two types of authentication, one is the agent inbound auth, the other one is the agent outbound auth. And as I said, the inbound auth is something that authenticates and authorizes the caller. And here there is also an outbound auth that will create for API or even calling some external downstream tools or other sources. So you could create that here using AgentCore. They do provide this ability to do this, and it's all about you should be able to know how SSO works, or how you should know how OAuth works. So if you really want to do that plumbing, I think with AI it's easy to learn all this. So if you ever want to explore this, please use ChatGPT or some of the things, or even like we'll also share a lot of resources on Agent University. So please do get into our Discord where we'll share all these resources. If anyone have any questions, we'll probably have that. Some maybe we'll have a session to cover all this. And coming to so as of now, we're not doing all of that. What we're doing here is we're asking LLM itself to do this authentication. So what we're doing is I'll show you this Gradio. Okay. So if you see here, there's a simple UI I've created. So what I did is I just created this broker profile. Have put my name is Raj, and I've also put my companies and what I do and which news feed that I prefer to get the news from, and about the technology and investment strategies growth. There could be different investment strategies because this profile is something that it uses, and it's also creating a user ID or an actor ID in its backend. So it's been a pretty simple LLM based authentication that is doing, because now LLM, when you go and say, hey, this is Raj, it will probably retrieve my memory saying, okay, this guy is into technology and this guy works for this company and everything, and he also has this risk tolerance of moderate and everything. So it uses that data, and now it gets the news, and it will give you an investment strategy based on that personalization, that hyper personalization, just getting things together, and it's hyper personalizing you with an approach. So that is what you could do. You can also create maybe it's something like Sarah. Maybe I'll just keep the same company advisor. I'll just keep all of this, and I'll just do a save profile. So now it just goes ahead and saves my profile in its memory. So it just goes in there and creates a user, an actor ID in the backend. So I'm just creating that from the UI, but you could probably do that from other things as well. Maybe through SSO if you're really part of authentic enterprise. So let me go through this code again. So yeah, this is something that's going on, and now we are instantiating the chat bedrock. So we are telling which model are we using. So we're using Claude, and if you see the temperature is 0.1, we have put very low temperature. I don't know if any one of you in this call knows what is the temperature. So it's one of the configuration item for a model for an LLM, because I don't want to go too deep into it, but when you put it low is when you want some information to be very deterministic. Maybe you're retrieving numbers or you're talking about finance and everything, your temperature would probably be really low because you want the answers to be more deterministic. You want highly probable answer. You don't want any kind of variability. Maybe you're talking about creating an AI agent to write a joke, or maybe AI agent to probably reply to an email in a funny way. Then probably having a temperature high makes sense, because then your output is you're introducing a lot of entropy into that answer. So that temperature really makes your model be more deterministic when you put it as low. So that's something that you can determine here. We are putting it as 0.1 for this use case. And creating these memory tools using memory tools module. So here what we're doing is we're basically creating these memory tools. Because as I said, we are treating memory as a tool because there is memory storage, but why do we need memory as a tool is our agent should know whether to update the memory. It should know when to save the memory. It should know how to retrieve the preferences. It should know. So this all happening through the memory. So it itself is treated as a tool that your LLM would probably retrieve and everything. And you'll see eventually how are we creating that? How does an LLM know that? It's really dumb. It's just some English that we write. So there's nothing really fancy here. But yeah, so what we're all doing here is the tool binding. So tool binding is how your agent, what are the different tools that your agent has, and we're binding that to an agent. So if you see here, get stock data is one of the tools because it has to go out and get stock data. There are different APIs that uses. Search news is also a tool. There's parse broker profile from message, generate market summary for brokers. There's get broker card template. There's also collect broker preferences. So there are a lot of different tools that you use to basically to bind these tools to an LLM. So LLM would know which one to use when. And also you're adding concatenating memory tools because I know this cannot be treated as a tool that like other tools because other tools are actual tools that LLM uses to function, whereas this is just to make it more so that it works on long horizon tasks. So maybe a broker coming after 2 months or 3 months would still have a hyper personalized responses by having these memory tools. And if you see here, there's LLM with tools, and you're just binding these tools with an LLM. And now you have a system prompt. So this is where all the magic happens. This is where you tell an LLM when to retrieve, what to retrieve, how to use a tool, all of that. So what you're doing is you're just typing down English, and you're just saying what to do here to answer this question. So if you see here, you're an expert market intelligence analyst with deep expertise in financial markets. You're just creating a persona, and you're telling you have advanced long-term memory capabilities to store and recall financial interest for each broker you work with. And here you're seeing a purpose: provide real-time marketing analysis, maintain long-term financial profiles for each broker or client, store and recall investment preferences, deliver personalized investment insights, build ongoing professional relationships through comprehensive memory. So these are things that it does. And what are the available tools? So in order to get the real-time market data, you're telling it get stock data. And you're telling, okay, this is the tool, and it retrieves current stock prices, changes, and market data. And what is the other one is the search news, with just searching for different multiple news sources for business news and market intelligence, because news does matter in terms of your real-time market. And broker profile collection, and how you are able to collect the broker's information, how you're storing it, right? These are some tools that you're using as part of maintaining this long-term memory, and these are the tools that are available for it. This is parse broker profiles, generate market summary. So these are all other tools, and these are basically some functions that you'd eventually see that are basically doing that. Get broker card template, collect broker preferences. Where do you see this? Okay, if you go into tool section here, you will see different tools. If you see the broker card tools, you see how the card tools work, right? So how the what are the things that you need from the broker, right? You probably need the name, company, role. You parse all of this information, and this is the tool that you're basically created here, which is the parse broker profile from message, right? You're telling when to do that. So whenever the user profile, whenever you get an entry of the broker, you're basically doing that. And as of now, I've created some data here, and it's able to do that previously. So it basically stored my profile here. And you see this information that is stored here. It's actually from the agent saying that it actually saved my data. It parsed it and saved it in its memory. And now if I come here and say, hey, hi, this is Sarah, then it'll probably customize the response for Sarah. Can you? Oh, maybe I'll ask. Uh, so I'm just saying this. So, now I ask the question. So this is the parse broker profile is what I have entered. I mean, ideally, you would need that information maybe from your SSO if you're really having an SSO, or maybe, as of now, I'm just giving it, ad hocly over that uh, template. And then, yeah, I think then you try, and you here you just parse for all of these details. And then you have another tool called generate market summary for broker. So what it does is it generates this market summary. So in order to provide the market summary, what it is doing is it has its own prompt where it says comprehensive market trend summary tailored for this broker profile. So you see there is a broker profile that is parsed here, and that is passed into this prompt, which is a system prompt. And your system prompt is not static, by the way. Here, if you see, there's a template. So based on the broker profile, if broker profile could be anything, it could be of Raj or it could be of Sarah. When it's generating the comprehensive market trend, it's actually taking the profile into consideration, and now it's hyper personalizing the response according to the whoever it is. And you're basically creating a structure on how to generate that summary. You're creating a structure to the summary here. It's also something that will tweak the behavior of your agent. Your LLM would respond back in the same format.
Raj, I wanted to ask, like here, when we are talking about the broker summary, where are we preserving the broker summary? Like,
Uh,
are we saving the broker summary somewhere within the function here?
Broker. Oh, here in this
I mean,
summary,
we are utilizing the broker summary, right? So,
broker profile,
are
right?
we persisting the broker summary somewhere?
Yes. I mean, this information is all again stored in the memory, right? It's all in the vector DB. All this information is in the vector database or in the memory.
But where are we specifying that this information should be saved? I mean, I understand that it is persisting, but shouldn't we like is there can I see that part of the code where we
Yes,
are like
yes, right here. So you're actually telling that here, right? You're telling available tools, and you're telling, okay, broker profile collection. You're telling, okay, this is what it does. It parses structured broker profile from user input, and you're telling generate tailor market, and these are the things that you're telling. These are available tools that you're giving it an LLM, but when to do it in the pass of action, when to call that tool is again the model that actually takes care of it. So if you see your broker profile management workflow, right? Mandatory broker identification first. So what you're doing, mandatory first step, identify brokers, right? Immediately use identity broker when any user message contain names, introduction, or I am. Broker cards or profile information, company names or roles, any identification information whatsoever. This returns the correct actor ID and checks for existing profiles. Use the return actor ID for all subsequent memory operations. Hopefully this makes sense. Maybe this should resolve your answer, your doubt, or maybe not. Like, are you still having
still a
some?
little bit confused, but it's okay. We can continue.
Because now, yeah, what's happening now is you're just telling the model you're basically telling the model a workflow. You're telling, hey, just follow these. And way to store, how to store. That storage is again a memory part physically, that's storing that in a vector DB and retrieving that from a vector DB. But who is doing the decision to store the broker information, when and what instance, when to call and get the broker information, is all something that the LLM itself would determine. That's a part of planning and self-reflection, or reasoning that the LLM does, because the LLM already has that information. It can do that. LLM is already fine-tuned to do these kind of cognition task, right? So it's LLM that decides when to do it. When to call a specific tool is then LLM's question.
And then
So
in the memory tool that we created above, like some a little above, we were
mhm.
mentioning about the session ID as well.
Yes,
So
yes.
how we are maintaining this session, and once
Mhm.
the session is closed, then what will happen in that case?
So yeah, that's a good question. So you're basically creating this session ID. Basically, you are storing that session ID for this conversation, right? And this session ID in LangGraph inherently stores that in terms of its framework itself. But I mean, don't I mean I understand now your question. Okay, if it is session ID, then who is I mean if the session close off, then the next request should be stateless, right? If the next request that's coming in is a
Yeah.
different session, how do you accept? How do you understand who is that actor, right?
Yep.
So that is something that is what it says here, right? But the actor ID will be determined from the user input. So now you have to come and say, hey, this is Raj, right? This is a dumb way of doing this, because if in case you really want this to be in an enterprise with proper authentication, the authenticated user would have, and you have the user ID mapped to the memory ID, isn't it?
Yep, yep, yeah.
Yeah,
So
that is
maybe
what,
this is a
that's what I
short
was
version
telling.
of, yeah.
Yes, that is what I'm saying. I know that is a missing part here. I mean, this is just an example that they have provided. So I haven't, if ideally, if you want to do this in enterprise, you would have someone log into an SSO. Your enterprise AD would already given your user groups and all the roles they have, and you map that into your tool's memory ID, right? And that is how someone logged in. Now your agent would know what is their memory ID. But here, what we're
Yeah.
doing is the actor ID will be determined from the user input. Like I have to come in and say, hey, this is Raj, right?
Yes, so we need
You
to
could go and say,
explicitly
okay,
tell.
this is Raj. Yeah.
Okay. Yep.
So, I mean, it's an
That was a
example.
confusion. Okay.
Yeah, it's just an example, right? That's the reason why it's happening like this. But, ideally, no, enterprise, that's the reason I was giving you this example. Hey, in enterprise, it happens in a different way. In enterprise, you probably do this. You have an inbound auth, right? You have an outbound auth. When you have an inbound auth, you map this inbound auth, whoever is calling you, that to the memory ID. And then you know how to, who is that who logged in and all, right? So that is something that you could do when you have the same stuff happening. Um, within an actual enterprise. But yeah, but this is just an example. So we are just doing a simple, we're not building an actual production, but if you want to really build that, you could do that. There's some examples which covered that inbound and outbound. So we could probably do that sometime, maybe in the next follow-up weeks, some event we do it. But usually it kind of takes more time, right? That's the reason why I just wanted a simple example and I did this. But if you really want to know the actor ID, you're just chatting with it, and then you say, "Hey, this is Raj," and then you know it is him. And that is the thing about it. See, now I asked it, "Hey, can this is Sarah. Can you top performing stocks?" It just went and did this. And I could also say, "Hey, this is Raj again. Um, you know, tell me about my preferences." So I'm again asking this question. So we can expect it to go ahead and see what preferences I have, because it might be storing myself as Raj somewhere, right? So yeah, that's going on here. And if you see here in the yeah, so you have this real-time data, you have the broker profile, you have memory and financial profile management. You have these are available tools, but yeah, this is the workflow. This is where we are now. Before, so checking existing profiles, right? After identification, we use this tool to identify the actor ID, right? Because now you know who's an actor ID, and if profile exists, acknowledge their stored preferences and personalized response. If no profile exists, proceed to collect new profile information. I mean, you're asking LLM to do your auth, which is really dumb, but still, this is just an example. We're doing it. So profile collection, this is where you're basically doing all the profile collection. You're also doing all the memory operations here. You're actually telling LLM, hey, how to do your memory operation. Always pass the identified actor ID to memory function, because now you're mapping the actor ID to your memory functions. And then you're getting the broker financial profile, and you're updating the broker financial interests. This so that you have this consistent broker identity across all sessions, right? That is what you're trying to do here. So you're basically typing down all of your robust memory operations as a prompt, and you're telling the model what to do when these events happen, right? So market analysis, professional standards. So you're basically prompting all of these into your system prompt so that your model does know what to do every time. uh, Immediate action required for every message. So before doing anything else, check if the user message contains name, broker cards. If yes, immediately call identity broker as your first action. If no, proceed with normal market analysis. So they're saying, okay, if you don't identify the user, just go with the normal. So even you don't even have to do any authentication is what they're saying. But yeah, so here is saying, okay, always use memory tools to maintain and reference broker financial profiles. This is essentially for providing personalized professional market. So you're basically writing down all of the manifest as a system prompt and telling the model what to do, how it is, telling the agent what to do, how you have to behave, and also giving you the complete workflow here, right? And
And
what
then
tools
this
are available.
system prompt should be given, like, it should be fed once only, right? Not every prompt, right?
You know what? It should ideally be sent.
It should ideally be sent every time, every
I mean, they
conversation
have,
message.
yes, right? I mean,
I
yeah,
think
it's
once in a
auto
complete
regressive.
session, once in a complete session, probably.
See, ideally. but it doesn't work that way because see, the thing is LLMs are auto-regressive. There is something called prompt caching. So they will cache this prompt in the model side, but this system prompt, that's the reason why as your agents evolve, they might forget some of the things. That's the reason why you have memory to it all the time. Look who is you're chatting with, because your context length may exhaust. They can exhaust really fast too.
But this way, like we are like giving so many tokens with respect to every prompt.
Yes, if you do prompt caching, yeah, you reduce that. But yeah, basically in your system prompt, that is something that everything is concatenated every time. That is how your agent is able to know, right? Because let's say if you have your chat GPT and when you're chatting with your chat GPT over one workflow completely, every time you do that, ChatGPT or your OpenAI might be caching all of it because you create something called KV cache. That's the reason why it's able to generate things really fast. But still, that exists in the compute memory of your GPU. That's the reason it's very expensive to run these models. It is not a simple Google search, right? It's more of a thing that thinks of, and the system prompt is always there. So that's the reason why your context lengths are increasing now. There's models with a million context and all, right? Which all things would usually happen in context too now. But yeah, the system prompt should always keep going.
Thank you for answering.
Yeah, yeah. I mean, yeah. I was surprised, but yeah, it does. But there's something called prompt caching. But
Have you seen my white borders?
so then, yeah, go ahead. What is this? Yeah, go ahead. You have a question? Okay. Okay. No one has questions. Um, okay, define the chat node with automatic conversation saving. So now you have this, and you're doing automatic conversation saving here. Um, um, and you create the chatbot now, right? And if you see here, the messages actually consumes all of these messages which are there. Um, and if you see here, uh, if you come down, yeah. Okay, so um, yeah. So if you see here, remove existing system is to avoid duplicates and all. But yeah, you're basically doing the same thing. You're coming here and then looking, and you're always trying to create system message. You already have a system message, and you're trying to avoid the duplicates because system message would probably consume all of your context length. But yeah, system message should be already sent to the model every time, and filtered messages. Um, and then you're just trying to check different messages and seeing if the messages has any kind of tool calls, and you're checking for all of them. So in the chatbot. So how, and also making it can save the conversation automatically here. I think even here you're just trying to save all of your I think you only have 12 minutes or 13 minutes, but yeah. So yeah, I think I mean, you could see here how we're creating the graph in LangGraph. So we have two nodes. One is the chatbot node and the other one is the tools node. So chatbot is the one a node that actually interacts as a chatbot, and the other nodes are all tools, which could be any tool. And you also have a conditional edge that will know whether the request has to be sent back to the chatbot or to a tool. A conditional, that is what a conditional edge is. And you have different edges as well, which is tools and chatbots it's a very simple graph. And you're also setting a entry point, which is again a chatbot. So because chatbot is the one that is chatting with us and giving you a response. So it's just a simple chatbot and a tool. So it's as simple as that. There are not any robust tools. There's not too many big workflows that we're building. But if you ask me, how would you create this? If I want to go into production with this, would I do that? Maybe not, because when you put so much information in your prompt, your AI agent might not always follow that. So what I would do is this complete workflow that they have put here, I would probably put that entire thing as a graph and add that entire thing as a graph. That way I know exactly that deterministically, I know that if what my model has done. As of now, still I would know it. I would know based on this output, whether it has called the tool on everything. But I don't have that control to drive that workflow. Sometimes it might call a different wrong tool and whole workflow might get messed up, right? So that, yeah, it's a simple example. Yeah, that's the reason why we're going through it. But if I would go to production with the same strategy, maybe not. I would change a bit. So,
Hey
and
Raj, I just had a question.
yes, go ahead. Who is this?
So in terms of how the data is retrieved, in terms of like what RAG are you using, can you maybe throw some light on that?
See, as
Or
of
how
now,
it's integrated with the code?
the RAG creation with the code.
Yeah.
Yes. So as of now, the memory itself, the memory tools are itself kind of RAG. They're kind of RAG because it does have to go ahead and retrieve the memory. So the tool call, the RAG, the tools for the memory is nothing but RAG. So how
Oh,
are we creating that RAG? It's pretty straightforward, right? I have put that in the code where I'm telling it just go ahead and if you see here in this code, I'm just asking it to retrieve the memory and use the memory tool. So a memory tool is nothing but RAG because now it has all of these previous conversations saved and persisted in long-term memory. Now you're going and retrieving that, right?
okay. So there's no separate source
No.
of truth that you're using apart from the what is stored in the memory.
Yes.
Okay,
You could
okay.
do that in evaluations. Maybe if you want to do that as an evaluation to check if your agent is performing well or not, maybe you could probably do that by having a source of truth. Maybe
Mm.
you just create some personas and also create some database or maybe some memory and ask it to just go retrieve it. And yeah, that might act in the evaluation side. But yeah, as of now, no, there's no. That's the reason the memory should be something that the model or the LLM should know exactly when to do a proper tool call because I mean, when it should know to do a proper retrieval, and it has to retrieve the proper memory from the information from all of the previous conversations it had, right? When a broker is
Got
talking to it, it should know initially what conversation it had, and also go and retrieve the broker profile. So it should know when to call, and that is nothing but a retrieval only that's going on here.
So it's kind of cached in the memory and you're retrieving from there instead.
Yes,
Okay.
not specifically cached, but it's actually stored.
Stored in the memory.
Yeah, it's
Got
stored in the vector DB. So they call it agent memory, but it's
it.
actually some vector DB that is storing it. So that's
Got it.
again RAG.
Makes
Yeah, any RAG, there might be a lot of. I mean, the reason why RAG is very important is because RAG could actually be memory for your AI agent. Yeah, that itself is an AI. It's a very important component. Yeah, maybe you could do that in two different ways. Maybe you have a huge document and you want to do RAG on it. One advantage is you have grounding. There's no hallucinations in it because now you know which data it is referring to give you an answer, right? And now the same thing in terms of agent too, right? When you're chatting with an agent and it is actually giving you a recommendation or chatting with you, it should be able to retrieve probably a conversation you had 3 months ago.
Yeah.
Maybe, maybe a client you worked with, or maybe some kind of event that happened in your life 3 months ago. It should always remember that. So it's if it is able to retrieve that properly, it means, yeah, your RAG is performing well. But now the RAG in the sense here is just your memories, your data that happened,
Makes
all of the
sense.
previous history.
In the real world scenario though, like when you actually create agents, how does it actually make use of RAG and then store it in the memory in terms of like what conversations it's like, just on a high level if you can share.
Yes, it does. I mean, you go, no, if you go into your Chat GPT and probably ask Chat GPT and go into your memories in Chat GPT, it will probably tell you all of your previous. You don't even in real life. You just get into your Chat GPT. I'll tell you. So just put it right here. So yeah, if you see in ChatGPT, you could come to there is a section in ChatGPT called in your settings. If you get into,
Mhm.
yeah, there is something called manage memory. In the manage memory, you will see ChatGPT storing all of this. It does knows, he has a 2-year-old daughter. Daughter Lena loves jellyfish, prefers meeting summaries to handle headlines, prefers assistance with writing blogs.
Yeah.
So in fact, your ChatGPT knows a lot of things about you.
Yeah, but like
Google.
this is again like what I have told it to like, or what it's stored based on our conversations. What I am
Yes.
asking is, let's say I ask it some question and
Okay.
it is trying to retrieve that, similar to what Google does, like in terms
Oh
of
yeah, it is
RAG,
the
right?
Google
So
retrieval part, right? Yeah, it is
yeah.
actually going ahead and okay, it's basically getting the outside resource, like maybe from Google,
Hmm.
to get an information, and now it has to understand information, maybe some event which happened yesterday, right? That itself,
Yeah.
that organ is a RAG, right? That's also
Right.
RAG.
Exactly.
Because now it is dynamically getting that URL content and storing in a vector DB and answering that. It's creating embeddings for that and giving you an answer in memory. Like it's
Oh, okay.
it's downloading
So you
that.
can integrate that in your Python code itself, what RAG source to use in your
Yes, that is what browser use is happening here, right? So
God.
when we do here, the agent core, it actually uses browser to go out and do research on this. So if you see the agent core, it does that research to find that information. Um, I think we have already seen that before. Yeah, let me store here. Even if you see the output of this agent, I can show you the logs here where you can actually see what it is doing, what's going under the hood on all the requests which I sent before. See
Exactly.
here, you can actually see it's downloading some of the it's actually downloading some of the content from different websites, and it is actually understanding that content from
Got
those
it. Got
websites.
it. Got it.
Basically doing
That's
two.
what I wanted to understand. Okay.
Yes, if you see here, right, it's also went in and it actually got in lot of the tools here already.
Got it. Perfect. Yeah. That's what I wanted to understand.
Yes. So yeah, it's the same rag, but this rag is happening, on the fly. It's going out, and that's the reason why when I was doing this initial profile creation, it was actually asking me what my preferences is and from where I need to get my news. Routers or maybe Bloomberg or CNBC, because it will go
Okay.
ahead
So
and get that information from those websites. It's
you're
scraping the.
giving it as an input itself, what RAG to
Yes, in the
use. Got
beginning. Yeah, I'm just giving the source for my RAG.
source for the RAG.
Yeah,
Got it.
source for the RAG. And now in the agent core, agent core already has a tool, and there is a built-in tool, and the built-in tool is called a browser tool. So this is a browser tool which is already created, and we are using this browser tool.
Hmm.
Okay, so if you see here, just now we did some of the searches. It went in and did all these sessions. It created sessions, means it went in and it actually got all of the information. So
Hmm.
there's also error rate. There's also how many connections it made to do that. And these are all
That's
terminated because it went in and did this research on the fly. When we're asking a question, it's actually going and doing this research now.
Raj, I
got it.
doubt if it is using the RAG architecture because it didn't mention where it is creating the vector databases and then do these comparison as the RAG does.
Yes, but if see
I
that's
mean,
what it's doing, right? As of now, it is basically using a tool as browser. So let's say it goes out, gets the content, right? Let's say if I want to, it has to go and get the stock information for now.
mm,
So how does it knows the stock information? How does LLM know stock information? Because LLM is only trained up till like last year, right? LLMs doesn't know dynamic information.
yeah.
But how is the
So
LLM able to answer that question?
yeah, so the thing is like there are different tools. For example,
Okay.
one tool, for example, like doing the calculation or
Yes.
like any other, but I mean, for example, the Wikipedia kind of tool, right? It can go and browse and fetch the information, but that does not necessarily means that it is utilizing the RAG architecture. Because for utilizing the RAG architecture, we should be creating the vector databases, and then the LLM should implement with the RAG architecture, like the prompt will be converted into the embeddings, and then the comparison is done uh, with the corpus of embeddings this way, which is different from just searching on the Wikipedia
So
or
see,
the browser.
there are two things we're talking here. So one is searching on Wikipedia to get the answer is a tool call. Okay, that is a tool call. It's basically using a tool
Yes,
call to get some data. Okay,
yes.
now you have this data. How does an LLM understand that information? Does it understand plain English? Does an LLM understand plain English? No, right? It does require embeddings too, right? Any information that you retrieve, it goes out and it does create embeddings for it, and that embeddings are something that the LLM should know exactly which will answer the proper question. Tomorrow it went out and got 10 different websites, questions from 10 different websites. Now it got all the data in files that needs to be again created as embeddings, and now it has to be able to retrieve the right information from those different sources, right? When it is
Yeah.
doing browser, it might also get some ad, which is not even giving its information. It just went out and did a browsing and it just got some advertisement. and now it knows it is not relevant. So it's actually RAG that is happening. But I mean, I understand in your case, you're thinking, okay, maybe it doesn't have that embeddings, but that embeddings are actually created because LLM doesn't understand plain English, right? It does have to have some embeddings. Okay, maybe there's no vector DB, it's all happening in memory, but it's also an in-memory vector DB that's existing. It may not be a vector DB that's physically there and persisting that transient information, right? Because it's not something that we can persist. It's just a browsing that went out, got the data, and now you're able to get the information right and give the information back to the user. So it's all RAG. It's all retrieval augmented generation only that's happening. Because if your LLM, if you without RAG, your LLM would only answer questions up till certain time when it was trained. It's only getting that information from its model weights, all something that it's memorized, isn't it? If you want to get a real-time information, it has to be able to get that information from the internet, and it has to convert that information into embeddings. It has to understand out of 10 different browsings or 10 different articles that it browsed and got, and now it has to be able to answer the question. So it is able to do that because it's all RAG that is happening.
But then that means like even if we are, for example, utilizing the browser
Mhm.
a tool only and the
Mhm.
LLM, right?
Mhm.
So we will say that we are utilizing the RAG architecture. However, as per my understanding, the
Mhm.
RAG architecture is when we have like corpus of database, like the documents that are converted into vector databases, and then we implement the LLM to utilize to convert the prompt into the embeddings and then like search. So per my understanding, that was the RAG architecture.
Yes.
Um,
I'm
I
see,
can
there's no wrong in
understand.
your understanding. There's no wrong in your understanding. What I'm saying is what's happening under the hood, even now, it's the same thing. Maybe you don't have to think you need corpus of information. You don't need like thousands of documents to perform RAG. Even a simple, let's say you go and upload a PDF into ChatGPT and now you ask it a question to probably answer some questions on PDF,
I
right?
understand what you are saying. Yes,
Right?
I that makes sense. Yes.
Yes. That's also RAG, isn't it? So that is what I mean. Yeah, what you have understanding is right. That's RAG. But now these RAG that is happening is on the fly RAG, right?
Okay.
Hopefully that makes sense. See, let's say like I'm using my coding agent now, and if I want to go ahead and ask a question to my coding agent, I'll just say, hey, can you go ahead and create this code? And I'll give you this documentation. So the coding agent should go ahead and get some documentation and give you the response, right? So
Okay.
for an LLM to understand any text, it has to be in terms of embeddings, right?
Okay.
And it will retrieve, augment, and then generate it. It retrieves, augments, and generates. That is what RAG is. It's retrieval, augmentation, and generation. The retrieval should not have to be from a corpus of huge documents. It could also be from a browser text that it went out and used a tool like a browser to get that retrieval. And now it augment that retrieval and generates the response.
So there
Even
is
for this to
no
generate stock information, it is able to do the same thing here,
so there
right?
is no kind of restriction of, or I would say reservation that a vector database should exist, which we can like think of.
Even here vector DB exists, right? Vector DB doesn't have to be always a vector DB. Even a simple uh, what is this hierarchical search algorithm, even this is enough. It's a simple library. It's a graph to retrieve what you're doing is a nearest neighbor search in the large data set, right? That is what you're doing,
Yeah,
right?
yeah.
You're doing a similarity search, right? And you're just doing it on a vector embeddings, right? So you don't
Yeah.
even you're doing this on the fly.
Okay, okay. I didn't know about that. Thank you for
Yes,
clarifying.
yes, that is what going on. It's all RAG that is going on itself. Even memory is nothing but RAG that's going on. Yeah, maybe you traditionally people use like Llama index, this and that, because yeah, that is a large scale. If you want to have a vector DB that is storing like huge amount of data and all, yeah, maybe then. But now if you're doing something on the fly and you don't need a huge vector DB, you can just do it on the fly, and you can use a very lightweight algorithm or a library like HNSW, that just a simple library call in Python that can do this. You don't even have a vector DB there. I think the RAG example or the RAG thing that we previously spoke about, that then I didn't even use vector DB. I just used a simple library. I think we had a session like few weeks ago on RAG, on multimodal RAG. Then I didn't even use the vector DB. I just used this library. It happens on the fly.
Thank you.
So yeah,
Thank you for
that is
clarifying.
what is RAG. Yes. But yeah, no problem. That's nothing to be confused about. But yeah, I think we are right on time. I mean, yeah, it was a great discussion. But hopefully Sonali and Ramana, I think you both understood a bit on what we were discussing here, what's RAG and all of those. But yeah, so yeah, it might be a bit confusing in the beginning. Yeah, but end of the day, yeah, it's all RAG. LLM, in order to retrieve anything, everything has to be in vector DB because LLMs cannot understand plain English. You already need to have to create embeddings for them, and then you feed into an LLM, and then the LLM would give you an output. Okay.
No, this is great, Rajdip. Thank you so much for
Yeah,
explaining.
thank you, Sonali, and others. Yeah. So I think we're right on time. But I will share this with you guys in the Discord. Please join the Discord channel. I think we're right on time. Okay, I've shared the Discord here, right? I'll probably do that again. Um, yeah, go ahead and give your introductions or whatnot. But yeah, just go ahead and be part of that Discord channel. If you guys have any questions, please feel free to ask. We are a community of quite a lot. I mean, on Charlotte, we have around like 2,500 people. In New Jersey, we have around quite a lot, maybe in thousands. And we're a growing community, so anyone could help you guys out. It's just not have to be, but anyone. It's more of synergy, promoting synergy, and having everyone upskill. So yeah, please do feel free join that Discord community, and we will have these events regularly. I really like the participation today. Hopefully, no one has any more questions. If you have any questions, we can stay. And I think Raj Shekhar, yes, ideal instance can resolve cold start. Ideal instance can resolve cold start, isn't it? No, I think yeah, it can resolve. I didn't understood this question that you asked, Rashikar. I mean, cold start problem is when you're usually lambdas, right? After a while, when you want to trigger lambda, it will take a while to give you a response because they have to spin up a VM and have the compute ready. So usually, what people do is they send pings to that lambda so that it is warm all the time. And Merzia Punawala, would web scraping functionality fall under browser tool? Yes, it does. Web scraping, yeah, browser tool, yeah, same thing. That's what's happening now. The web scrape, but no, there are two things here. Web scraping could be headless. So headless means some process or the script can go in there and scrape it out, right? Browser tool is something that you're opening it in a browser. So when you're doing headless, the problem with headless is when you're going and scraping through it, there could be restrictions. There could not be a lot of information that it grabs. There could be some websites that it cannot get. It should probably require. Now when you're doing a when you use a browser, you capture more semantics. So just like using automation versus a human going out and using a browser, when using a browser, it's more robust because now it can capture a bit more richer information because the model is able to use the vector. It's able to use the multimodal capability. So the multimodal capabilities of using a image, seeing an image and understanding the world. So a browser tools could be a bit different than a regular web scraping. But yeah, they both can be treated. One will be scraping off, the other one is basically just like a human going out and using it. Is this just reading the website, trying to understand scope of the tool? Yeah, I just reading the website and just get the data by having a browser do it. Um, okay, sounds great. I think I've shared the Discord too.
Can you share your GitHub?
Yes, I will share the GitHub. I don't think this code is pushed in the GitHub yet in the Agentversity, but let me see if they pushed or not. If it is not pushed, then probably I will go ahead and push this code because I have a UI for this code. So Yeah, I think only for multimodal RAG we have this. Repositories. Okay, I think there was something that was pushed recently by one of the team members. Okay, yeah, let me share this. It just has this, it doesn't have the UI code, which I'll push it maybe in the next few hours. And I'm putting that here in this chat. Yeah, this is the GitHub. Okay, sounds great. If Yeah, that's great. Thank you, Sam. Yo, yeah, that's a good, yeah, dynamic RAG and static RAG. Yeah, that's a good I think that's a good way of mentioning that. It's a dynamic RAG and static RAG. Yeah. Oh, really? Okay, maybe it was not open, Doug. Let me make that a open repository. Um, yeah, I think he made it private. Let me make it public. It looks like, yeah. Okay. Okay, I might take a while to do this because it's asking for my authentication and my phone is probably not nearby, but I'll probably do this shortly, where I'll make this public and share that in Discord. So please do join that so that we can just keep the discussion going on. So that if anyone wants to work on this, please do, and also shares the the thing. Thank you. Okay, everyone, I'm
Can you
stopping this
post
call.
the Discord link as well?
Oh yeah, I did multiple times. Let me do that
Oh,
again.
sorry.
Yeah,
Yeah.
no, let me do that here. If you see this is the Discord link right here, and I can also do on Luma as well. So the Luma and Meetup, anyone who wants to join the Discord.
Thank you.
Sounds great. Thank you all.
Thank you.
Sure, sounds good.